this video, we're going to work through the molecule PCl3. The name of PCl3, being that it's covalent, we use prefixes. So the first element is phosphorus. Because it only has one, we don't use a mono. And the second element is chlorine, so we're going to change it to chloride, but there's three of them, so the prefix for 3 is tri, so it's phosphorus trichloride. And we only use prefixes when we're dealing with covalent compounds. The bond type we figure out by looking at the electronegativity. So the electronegativity chart, we're going to take a look at P, which is 2.1, and Cl. So in PCl3, I don't worry about the 3, because I'm looking at just the bond between one P and one Cl, not 3 Cls. Don't bond to 3 at one time like that. So what we do is we subtract the higher from the lower. So we see it's 0.9. So the magic number is 0.4, and as long as I'm less than 0.4, I know I would have a non-polar, which means equal sharing of electrons. But in this case, it's 0.9, which is greater than 0.4, so I know I have a polar covalent bond. So that's my answer for the bond type. It's polar covalent. So then really the hard part is to draw the Lewis structure. And so there are a set of steps that we can do to go through this. So if we have our PCl3, I know that the first step I'm going to do is solve for the valence, not the outside valence electrons, for the total molecule. So the total valence is, you take P, so P is in group 15, has 5, plus chlorine. Chlorine has 7. He's in group 17, but 7 times 3 is 21. So I know my total valence is 26 electrons. So what's going to happen is I need to share those 26 electrons to make everybody in this molecule stable. So to do that, I'm going to now move to step 2. It says place the central atom, and this is usually the one that has only one of them. And so I'm going to put, and I'm going to go ahead and just do this on a new page. So I have PCl3. I need to decide who's my central atom. Well, I only have one P, so that's usually the winner. So I'm going to put P in the center, and I'm going to connect the 3 chlorines to the central atom. Well, again, my bank of valence was 26. What we need to understand is by connecting them, that is actually called a sigma bond, and it represents 2 electrons. So just in the connection, I used up 2, 4, 6 electrons. So I've spent 6 electrons, and I have 20 remaining. So now how to decide how many more I need is that pretty much most elements want to have a total of 8 electrons. So I'm going to look at my central. My central has 2, 2, and 2. So it has a total of 6 around it. So P has 2, 4, 6. So it needs 2 more. So I'm going to draw those as lone pairs. And so now he has 8. But I just spent 2. So now I'm going to subtract 2. And I have 18 remaining. This also has a name. This extra pair of electrons I just drew is called a lone pair. So those lone pair electrons are actually going to affect the structure of this molecule. And we'll see that in just a minute. So now I'm going to take a look at the chlorines. Well, chlorine currently has 2 electrons. This particular chlorine here I can see has 2 electrons from this pair, from this bond. And so he needs a total of, I'll have 2, I want 8, so I need 6 more. So if I add 6 more electrons, and we can represent that by doing dots, it's my lone pairs. And I'm going to do that all around. Now another way we can represent that is by drawing a line. So sometimes for these outer elements that are on the outside of the central, drawing a line is just a quicker way to do this. So what I just used up then is each line is 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So I used up a total of 18, so I have none left. Well, a good idea is to make sure that I actually use the 26 electrons, no more, no less. And so I'm going to count those real quick. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm good. So just very quickly, again, I'm just going to draw this to just clean it up. So phosphorus in the middle. I'm actually going to draw it a little bent down because that's what this lone pair does. The lone pair will push those chlorines down, causing it to skew the shape a little bit. And then I'm going to add my lone pair electrons around the chlorine. So that's what phosphorus trichloride would look like. So if we go back to our list then, I'm just going to kind of, again, just really quickly draw the Lewis structure. And I'm going to check now, I'm going to check the shape. Now to do shape, we're going to use what we call our VSEPR chart, valence shell electron pair repulsion. So what we're going to do is we're going to look at our molecule, our PCl3, and we're going to count. So all I care about at this point is I only care about the P. So I look at P and I count. Oh, I have one set of lone pairs. I have 1, 2, 3 sigma bonds. So I'm going to go find that on the chart. Normally we're going to be in the normal molecules will land in this 4 because everybody wants to have 8 and 4 times 2 is 8. So that's how many are going to be around the central atom. The other realms, the 2 and the 3 and the 5 and the 6 will be exceptions, and we'll see some of those. But on this particular time we have 4 because I have, if you take a look, I have one lone pair. This is my lone pair. I have 3 sigma bonds. So it's easy to see what the shape is. So I have 1 lone, 3 sigmas, so my shape is trigonal pyramidal. So I can come back here and write that in for my shape, trigonal pyramidal. Now to be able to answer this next question, polar or nonpolar molecule, I just need to ask myself a couple questions. Okay, to be a polar molecule, it has 2 criteria. Criteria 1 is I have to have a polar bond. Criteria 2 is I have to have an asymmetrical shape. Because the definition of a polar bond is when 1/2 of my molecule is positive. It's kind of like a magnet. 1/2 is north, 1/2 is south. So 1/2 of my molecule is plus, and 1/2 of my molecule is minus. And so, first of all, I have to have a plus minus. So that's where the polar bond comes in. And then that plus and the minus have to be away from each other, and that's where the asymmetrical shape comes in. So when I take a look at the PCl, I do have the check, polar bond, yes. But then what about my asymmetrical shape? Well, if we go back to our VSEPR chart, there are certain ones on here that are asymmetrical. So the ones that are asymmetrical don't start until, well, we're here. Our asymmetrical shapes are right here. So the angular shape is asymmetrical. You can kind of see if this was plus and this was minus, they could be away from each other. The other one that are asymmetrical is the tetrahedral. So what I'm going to do is just kind of circle the ones that can be asymmetrical. Notice that they pretty much are the ones that have a lone pair. So when you have a lone pair, you can be asymmetrical. So on the advanced ones, the ones that are asymmetrical here, is I have the seesaw and the T-shape, and then also the pyramidal square planar. So if any of your pictures, any of your shapes fall into those categories, then you can be polar. So look where we were. We had a trigonal pyramidal. That's a possible polar shape. So I know 2 criteria, polar bond, asymmetrical shape. So this is a polar molecule. Any of those were no. If it was a nonpolar bond, I'm a nonpolar molecule. I have a symmetrical shape, it's a nonpolar molecule. So you could have a polar bond, and then you have a shape that's symmetrical, you're still nonpolar. Okay, last but not least, we're going to look at the state of matter. State of matter is pretty easy to figure out. It's based on mass and what type of molecule you have. And so all we do is we add up. Now, the state of matter is figured out by looking at the periodic table. So when we look at the periodic table, we go, I don't know if my periodic table has mass on it. Nope, it doesn't. So what we have to do is we have to look up the periodic table, look on the periodic table, and look for the mass of each element. And so if we look at P on the periodic table, its mass is approximately 31. Chlorine is 35.5. We're going to take that number, we're going to multiply it by 3 because I have 3 chlorines. So I'm going to add all that up. So I'm just very quickly going to take those numbers and add them up. And I end up with 137.5. So then what I do is I go to my chart. Let's go through our charts and see. And I look at the state of matter chart. And so I know that this was a polar molecule. And it has a mass of 137.5. So it's a mass greater than 100. So I know it's a solid. So that's the last statement that I need to make. That this molecule is a solid. I know it's a polar molecule, has a trigonal pyramidal shape. I know its Lewis structure. It's a polar covalent bond. And its name is phosphorus trichloride. So a lot of information just by looking at a molecule. I'll do another video later of the other two elements, SO2 and TeF4.